this video we're going to be setting up the Bibo 2 dual extruder 3D printer to work with the Octoprint print server, which is a Raspberry Pi based operating system / 3D printer manager. Now the reason we're setting this up is to gain some more functionality over the 3D printer, as well as mitigate some issues that I was having with this 3D printer trying to print via the SD card or the USB slot, or with it connected via USB to my computer itself. So with that said, let's get started. For this project we're going to need a Raspberry Pi. I used a Raspberry Pi 3B. Any model of Raspberry Pi will work, however the Pi Zeros are not recommended for this application by Octoprint. You also need a Raspberry Pi power supply that gives the proper 2.5 amps, as well as a micro SD card to write the Octoprint image to, and obviously some kind of reader or adapter to load that image onto that micro SD card, and finally a USB-A to USB-B printer cord, which should have come with your Bibo 2 dual printer. One cool thing about Octoprint is it allows you to integrate a camera inside of your 3D printer to do time-lapse or error checking or other items like that. This is not necessary to set up Octoprint with your Bibo. However, the added functionality is really great in my opinion. So if you want to pick up a Raspberry Pi camera as well as a 1 meter Raspberry Pi camera cable, we go ahead and set that up at the end of this video. So to begin the setup, you're going to go to raspberrypi.com/software. Once on that site, you're going to scroll down and install the Pi Imager for whatever operating system you're using. Once that's downloaded, go ahead and run that executable file and go through the install prompts. Let that finish up. You'll come to this screen. Here we're going to choose the operating system. So here we're going to scroll down until we get to other specific OS, specific purpose OS. And we're going to select Octoprint and Octopi. Now go ahead and insert your micro SD card into your computer. Before we complete, we're going to hit Control-Shift-X to bring up a hidden menu. We're going to go ahead and enable SSH and set up a password to remote into the Pi. And then we're going to configure Wi-Fi so it'll be able to immediately connect to your Wi-Fi network. Go ahead and put in your SSID and password, and then we'll need to select the country. This is a little poorly set up, but if you get all the way to the bottom, you'll finally find US. Then you're going to go ahead and push save. And then go ahead and hit the right button. Please be sure that the micro SD card that you're writing these files to does not have any important information or files on it, because they will be erased. And the write process will begin. Now this does take a little while, I'd say 10 to 15 minutes, depending on your internet speeds, but just let it run its course. I've gone ahead and speeded this up by 1000%, so we're not here watching it for no reason. Now once this is complete, You can go ahead and open up an internet browser and start typing in the IP address for your Raspberry Pi. You can find the IP address for your Raspberry Pi via your router's internal settings by looking at the device list. You'll then land on the setup wizard. You're going to advance to the next pane here and set up your username and password for your Octoprint account. Go ahead and create an account and click Next. This page is for if you want to do any port forwarding or other networking connections, but you can just advance through that. If you want to allow Octoprint to track your usage, go ahead and enable that. And then the final enable is for the plugins blacklist processing. I recommend enabling this. Now you'll start to set up your printer profile. Go ahead and give your printer a name. Here we have the Bibo 2 Dual. And you'll go ahead and advance to the next screen. And click Finish. And this is what the main splash screen of Octoprint will look like when you connect to it. Here in the little setup wrench, you'll be able to set up the printer profile. Within here, we'll go ahead and start assigning the properties of the printer. So for the width of the Bibo, we're at 214 millimeters. For the depth, we're at 116 millimeters. And for the height, we're at 160 millimeters. There's a heated bed, and the form factor is rectangular. The origin should be set to center, not lower left. That was a mistake I made in my initial setup. Here is the speeds at which the axes travel. The only thing you should do here is hit invert control for the Z-axis. Again, something I found out later. And the Bibo 2, as you know, has 2 extruders, so we're going to go ahead and set that up. The nozzle diameter is 0.4 millimeters, and here we'll enter the offset of the second extruder relative to the first extruder. Every printer is a little bit different. There should be a sticker on the back of your printer that outlines the offset parameters. Now you've successfully created the profile. So now we're going to go ahead and jump back to the main screen and hit the connect button now that we've physically connected the printer to the Raspberry Pi via the USB cable. We're going to go ahead and grab a G-code file and just drag it over the web page until it uploads into this little menu here. The far button that I just clicked will immediately load and begin the print. The button immediately to the left will just load the print so you can look at it prior to actually starting the print job. You can see the printer disconnected on me here. Went ahead and reconnected it, and everything went back to normal. Go ahead and hit print again. Now I have an under voltage problem right now because I'm not using the Pi power supply, but we're going to go ahead and order one of those and run through the print anyway. So you can see here this main screen shows you primarily the temperatures of your 2 extruders as well as the bed. If you go to the G-code viewer, this will actually show you what that print is going to look like layer by layer. You'll see here this is where I previously messed up by selecting lower left as the origin, so the part is off of the print bed currently. We'll go ahead and adjust that setting to be center instead of lower left, and that should fix the problem. I'm going to run the print again and go check out the G-code viewer one more time. Here now the part is now in the middle of the print bed, so we're going to go ahead and let this one get printed. The G-code viewer, I think, is a very powerful tool that Octoprint has laced into their setup here. It really does allow you to see clearly what the printer is going to do. It has a lot of options to see first layer, next layer, and while you're printing it will actually track the nozzle movements, so you can see them in real time. So I just wanted to show the live view on the G-code viewer. This here is a different model that we're printing, and as you can see my settings down here, I've got the sync with job progress as well as center. If you click the zoom, it'll zoom in tight on the object itself. We're showing moves, retracts, and the approximate print head position. Right now, previous layer as well as current layer. If we set the next layer on, you would see that as well, but the next layer is the same as what we're printing currently. But again, this is super cool to be able to see what the printer's actually doing. Here on the control tab, you'll see your basic controls. Like these are disabled because the printer is actually printing currently. And then if you do have a camera set up, you can log in here to see the progress of the print or see if it's gone awry while you're printing. Here on the temperatures tab, you'll see the temperatures for your two extruders as well as the bed, in a tabular format at the bottom as well as a graphical format at the top. Moving on to the terminal button, here is the G-code that's being sent to the printer live, if you're interested in that. The time-lapse button is where your time lapses will be saved, again if you have a camera, and the Octolapse is a plugin that we've added to run some time-lapse that allow the print head to be kind of out of the way, and we're going to set that up next. So now we'll get into the setup of Octolapse to take your time-lapse videos for you while you're printing. To begin this process, you're going to want to go up to the little gear or wrench icon, and then go to Plugins Manager. In the Plugin Manager, you're going to go to Add Plugins and search for Octolapse. Now, I already have it installed on this instance of Octopi, so it's not going to show up here in this list, but you should be able to find it there. Click Install. It will start the download and write process, and then we'll ask you to restart your Pi, which you'll go ahead and do, and then upon that restart you should see the new Octolapse tab in the main splash screen of Octoprint. Now, when you first click on this, after installing, a series of windows will come up which will ask you to fill in your printer settings. Again, I already have this, so I'm going to navigate to that same screen that you should see right now. So here is the settings setup. You're going to want to name your printer up at the top. If you want to add a description, go right ahead. And then basically you're going to start setting your slicer settings. Here it asks you what slicer you're using. I'm using Cura 5, so I'm going to select Cura V4.2 and above. And we'll continue down. My default layer height is 0.2 millimeters. And then my extruder settings, these come directly from Cura. Some of these I've edited, but most of them are the defaults. You'll have to look through your Cura settings or whatever slicer you're using settings to input that data appropriately to match. Down here at the build volume and origin, you're going to set the shape to rectangular and input the same build volume metrics that we did when we first set up the printer in Octoprint. And again, we want to make the origin type center. Moving down here, we're going to basically save the default layer change detection measurements that came with the setup of Octolapse. I didn't really change these, they seem to work fine. We have position detection enabled, and as far as firmware settings, I've left all of this as it came with the original install of Octolapse. Now, the one change I did make here is the number of extruders. I changed this from 1 to 2 because we have a dual extruder printer, and that is what enabled this extruder 2 pane here. You won't have that until you select this field and change it to 2, at which point, again, you'll get that second extruder window, and both of these settings are identical for the 2 extruders. And that was basically all the setup that was required. I didn't change any of these other fields, and again, the time-lapse seemed to work well for me. If you're looking to get a little more intricate with it, by all means go right ahead, but this was plenty for me at this point in time. So you're going to go ahead and hit save, and then save again. But before we do that, I'll just tell you I have my positioning set to back left for the stabilization. That moves the heads to the back left before taking a picture. For this setting, I have it set to smart compatibility. This basically looks for the next layer and then takes the picture. The output settings for the video file I have set to MP4 60 frames per second. Again, didn't change that. The camera that we're using is the Raspberry Pi camera, the only camera we have hooked up, and again, this setting was default. I've got this set to log all errors. Not sure exactly what errors we might get, but at least we'll see all of them if they arise. And we'll go ahead and hit save, and that is the bulk of the setup for Octolapse. Again, down here at the bottom of this window here, those same last few settings that we discussed are loaded here. We have the printer profile, the back left stabilization, the smart logging for the layer change, the 60 frames per second for the video output, and then our logging of all errors. We've got these buttons here enabled, as well as the main enable button at the top of the window, and I'll just show you guys the last time lapse that I took from my last print, just for some frame of reference. As you can see, the build plate on this printer moves downward. It's kind of a strange time lapse, but that's just kind of the nature of the printer. Most of them you see, though, the build grows vertically instead of this one where it grows in the downward fashion. And when you go to hit print on your next model, now that you've got this set up, this window will show up here. And basically this is telling you or showing you what its plan is to take these snapshots. So here at the start, that's where the heads will be. During the snapshot, then they'll move to the back, and then after the snapshot they'll return back to the print. And so if you accept these changes, your print will begin and your Octolapse settings will be in effect for that print. And that pretty much wraps it up for the setup of Octoprint with the Bibo 2 Touch Dual Extruder 3D printer. Again, Octoprint is an open source software package that you can load onto any computer and use it with any 3D printer. Here I just have the Bibo 2 dual printer, and not only has Octoprint allowed me to use that printer at a higher functional level, but it's also mitigated some of the many problems I was having with the printer early on. So I highly recommend this setup. Well, hopefully you guys have found this video to be helpful or insightful. If you did, please like and subscribe. And if you have any comments, questions, or suggestions, please leave those below in the comments. And again, thanks for watching.